Hello everyone, this is Keith with Possum Sausage Forge. Tonight I'm working on a like 17 to 18, late 17 to early 1800s belt axe. I've taken this is a piece of 1" by half mild steel. I already forged out the eye, wrapped it around, and now we're going to forge weld the eye closed. You can see that seam right there. You can see the scarf I put on the end to be welded. I'm burning a new type of fuel. It is just stoker coal. Super cheap. Problem is it's dirty and you have to coke it out. So a lot of fire maintenance. I'm still learning that because I usually just run straight coke. So it takes a lot more work to, on the outside edges of your fire is where your fresh coal is. And as it burns the impurities out, all the oils and tar, it becomes coke. So you have your fire pot with your raw coal on the outside. As all that garbage burns off, it becomes coke. That's what you rake into the middle and you re-supplement it with fresh coal. So it's a lot more maintenance than just burning the pure coal or pure coke like I've been doing. But it's also a lot smaller diameter. So here's the coke I've been using, decent sized. Here is the coal. So you can see the size difference. The coal has a lot more surface area, burning, more BTUs. That has bit me already with forge welding because the higher BTUs heat up the surface of the steel faster, making the steel look like it's ready to weld, but the core is not to temperature yet. So it's definitely a learning curve for me, but I have forge welded with this and it's still just as fun as forge welding with coke. Stoker coal also puts out a lot more smoke because you're burning off the impurities. So make sure your neighbors don't mind. What I just did right there, a little trick I learned. You take water and you sprinkle it around the outside, the coal that is coking out. And as it heats up, when it turns to steam, it basically steam cleans, from what I understand, the coal. And it helps the process of coking it out. You can just burn it, but it turns into a sludge and it's real hard to move around. It seems like if you use that steam, it really helps to make a cleaner coke. This is already heating up pretty nice. Sprinkle some of that magic forge welding glue on there. Just kidding. That's not glue. All that the flux does, for anybody that doesn't know, it melts, turns into a liquid, and through capillary action, if your joint is fairly tight, through capillary action, that liquid will get sucked into the joint. And then when you go to set the weld, your hammer blow squirts all the flux out. And it carries with it the oxides. The flux does not help the metal stick together. It does not prevent oxides from forming. Borax, I believe, is acetic in nature. Well, what does acid do to steel? It causes it to oxide, tarnish, etch. So all the flux does is creates a wet layer between the layers of steel that squirts out easier. Some manufacturers, like Iron Mountain, I believe, flux, they add high carbon powdered steel essentially to their flux. Now what that does, high carbon steel melts or welds at a lower point than mild steel. So by introducing that high carbon steel into your flux, it'll melt faster and it'll allow your steel to weld at a lower point. But at the end of the day, the flux has nothing to do with, you know, actually making the steel stick together or preventing it from oxidizing or any of that jazz. Alright, I think we're here. And one way you can tell, won't be able to see it on camera, it's too bright. As soon as I started hitting that, the area that I had folded around that had the scarf on it, it was a slightly lower temperature. I could see the color difference. But it was at the lower end of welding temperature. So, got this part, I'm folding around. This point was a lower temperature because I had it up in the fire. It's thinner. I don't want it to overheat, so it was away from the fire. The body was closer to the fire, so it was hotter. So when I fold these over, which I can't, do with my hand. If you can, you're weird. When this came down to set the weld, this was a darker color. It was like a bright orange, whereas this, not bright orange, more like a medium yellow. This was about white. Not quite white. It wasn't sparking. You could see when I took it out. It was sizzling a bit, but it wasn't, throwing sparklers. As soon as I started tapping on it, this piece started glowing brighter. Because it's thinner, it's now married to this piece, which is hotter, has more mass. This heat soaks into there, heating this piece up. So I can immediately tell it was a good weld. But don't get carried away with it. The first weld is still more like a tack weld. Now those pieces are stuck together good. We'll go back in the fire, take another heat with this piece up again, because it might not be 100% welded. It might be, 70% welded. Hopefully it's 95% welded, could be 50% welded. So with this piece up again, I put more flux on it, just a little sprinkle, dabble do ya. Go back in the fire, I'll set a second weld, really get that squished down, worked in, then probably brush it and reflux it. I'm going to come over this way make sure to get good heat on that flap that I folded over, and that's where I'll clean the weld up. I'm also going to switch out to a bit lighter hammer. I had that hammer out. It's a 2.5 pound, 3 pound. I think it's 3 pound. No, that ain't that much. It's got a 3 stamped on it. Working on a double bit axe, forge welded. It's 2 plates of mild steel with a piece of spring steel on the ends. You forge weld the ends together. That leaves the slit, which then you can spread apart to create the eye. So I got done working on that tonight. Going to grind up all my seams, make sure there's no D-lams in there. I've been fighting D-lams on this guy, trying to, you know, learn the new fuel. Like I said, those higher BTUs, it makes the steel get up to a forge welding temperature, and I think I'm there, so I go ahead and stick the weld. It sticks, but it's probably only stuck like 25%. Then you get to shaping or drawing out, and it just comes apart, so you go back to forge weld again. Just lather, rinse, repeat. Should probably spend more time cranking the blower than talking. Luckily it's just mild steel, not have to worry about it cooking too long. That's good. I'm going to go ahead and start shaping this back end just a little bit. Try and get it trued up. That's all welded. So now give it a light flux. Go back in the fire. I don't know that I'm going to go with that welded the scarf portion down like I've been, or like I was saying. I may just keep that scarf up. I don't know that really matters at this point, but I'll do one more heat, just going straight down. Really kind of focus on that stock thickness. And with welds, this, let me flux this real quick. So with forge welds, here's a pair of tongs I'm making. Don't have good lighting in here. It has welded reins. I weld the reins on. I can just see the scarf right here. This other one, or the other side, pardon, is right there. I have maybe 1.5 inches of overlap. When I weld reins on, I overlap the rein onto the little tang coming out of your boss. All of my welding heats, you know, the 3 heats, 2 heats, whatever I take, they're all coming down this way, setting the weld. Once you get it worked down to the thickness you want, you turn it up this way, you'll have a big bulb right here. But you have the two welded surfaces, and they're never in line. Unless you're perfect, you know, balls on, you're always flipping your heats back and forth, working the material the same. So you get those off. Well, all you worry about is getting your thickness consistent. Then you come up this way and work your stock down. That'll get rid of all of those misalignments, and you work it at forge welding heat. You get everything worked back down at forge welding. You know, if this wants to curl over, get in the camera. So say you're like this, got it down to the thickness you want, come up this way, it wants to curl over, who cares? As long as you're at forge welding and you can weld it, that's welded. It gets rid of all your seams. So you always weld from your first plane, get a solid, you know, 2 if not 3 welding heats, and then go to your shear plane and dress it out. Now this one, it does need a little cleanup on the shear plane, but it doesn't need a bunch of dressing in. So I've already got it 2 good welding heats, got them welded together. This third heat, I'm going to come back on that same plane. I'm going to quickly go over it, dress it down to thickness, then I'll stand up on the edge on the shear plane, clean up those seams. Might go back and forth a little bit of fiddling around, but I think 3 heats and we have it. And also I was going to video it, completely slipped my mind, so I apologize. I had a friend with a leg vise. The leg was broken off right underneath the hinge plate, whatever it's called, for the jaw. There is a little bit sticking out below it. I had some 3/4 inch round bar, and we forge welded a new leg on the bottom of it. Made an Instagram post about it with pictures, but like I said, I completely forgot to video it. There's little spots here and there. I can just see through the coke. I can see that we're getting up to about a yellow heat. So I'm going to ease off the air a little bit. Try and keep it from oxidizing. I don't know the exact data when steel starts oxidizing. I believe it's around 1,000, 1,200 degrees. But I do know the hotter it gets, the faster it oxidizes. So you want to keep that airflow as low as you can while still supplying the fire to generate more heat. Got a couple little sparklers coming out. Little trick I learned from Roy. Still sparkling. That was plenty hot. This one will just have a bit more character to it. Going down against the shear plane now. Dressing that up, go back from the side, get all this evened up. Oh. clean up those cheeks a little bit. Now I'm just kind of dressing everything up, knocking in my corners. This will be kind of a cross between a belt axe and a tomahawk, but originally the definition, if you will, of tomahawk was just a small axe. Tomahawk is actually a Native American word. So you can see that eye is all sorts of boogered up, but that's fine. You can kind of see the end of the scarf right there, but can't see any weld seam on there. Can't see any weld seam on there. Just the end of the scarf. But that little thing that I said, I learned that from Roy Adams at Christ Centered Iron Works. If you pull your steel out of the fire and it's sparking, it's way too hot to do anything with unless you're casting. You take that, shove it into some coal or coke that is not burning, just like black, on the side of your fire, and the heat from the burning steel will try to ignite that coal or coke. Well, when it's trying to ignite, it's consuming oxygen, which means you are making basically a reducing atmosphere, and your steel will quit sparking. Your steel, it doesn't cool your steel down, but it will keep it from actually burning, because it's eliminating oxygen from right around it. So that's a very handy little tip to know, especially when you're, every time you light the forge, you're forge welding like I am. But, so now, next step, I'll probably just take a little chisel, spread that eye open, run a drift in there. Got my hammer pole, and this is just mild steel, so I'll chop it off maybe about there. Kind of draw out the bit a little bit, and then from the double bit that I made, I've got this drop of spring steel from a leaf spring. So I'll probably insert that, forge weld it. So I'll cut this off, draw it out till it matches this width, forge this into a wedge, insert it in, forge weld it, then kind of draw it out just by eye till I get something I like. But anyway, that's forge welding a wraparound eye with a bit of rambling. Hope you enjoyed watching it, and hope you learned something. Got any questions or comments, please leave them below. Give me a like and subscribe if you haven't. Thank you.